Well, hi, good morning. Thanks so much for coming and joining me in my shop here. It's now September 17th. I've lost track of what I've posted of my work on this radio and not posted, because I have not posted quite a bit of stuff. But it's all led to almost a disaster. Let me just turn this on for a sec. Have a listen. The way I got there is not the way I should have got there, and I'm going to tell you the story here very quickly. If you've been watching all the videos, you know most of the story. Actually, yeah, you would know most of the story, but there's a lot more to it than what you've seen. So let me just go through it. Got this receiver. Someone purchased it not knowing if it worked or not, or how well it worked. Got it here, decided I'd change the electrolytic capacitors in the tuner. In the receiver part, not the amplifier part. Did the work, decided I needed to align the radio. From there, it's been a spiral basically downwards as I've worked on this radio. I made the situation much more complicated by deciding I would investigate some of the equipment I don't normally use in my shop in an effort to find some better piece of equipment. I have a great piece of FM alignment equipment. It's this guy sitting right here. But he's stuck on one frequency, 100 megahertz. And so there are times where you want to tune to the edge of the scale and check things out. But this guy can't do it. He's stuck at 100 megahertz. So that got me interested in this Heath kit up here. And I spent a fair bit of time working on this Heath kit. Now that's not a stock Heath kit. There's an additional circuit in it. All that was extremely confusing, but I managed to sort the whole thing out, except the extra circuit. And I started utilizing this guy. He has a huge sweep and easily reaches all the frequencies that an FM radio wants to use. I did have success in using this. After an awful lot of effort, I was able to use that sweep and my scope to produce the response curve, get it shaped pretty much just like this. But the next problem was to try to mark these frequencies here and ensure that the bandwidth was proper. On my initial IF alignment, I aligned the IF to be very, very tight. And then when I carried on to do the rest of the alignment, that tight response made it all impossible. You can't have that tight a response curve in a radio like this. The radio's IF response curve has to be fairly open to let through the rather complicated composite signal that the FM station is trying to send to you. So again, using the Heath kit and using a marker amplifier, using this one, marker generator rather, I was able to get, after a lot of effort, marks sufficiently tight to believe and trust and set this curve just about exactly right. And I felt really good about it. Don't know if I posted a video showing that or not. But I did get there. The radio was working reasonably well. Wouldn't turn on the stereo light. The stereo light would not come on no matter what station you tune to and that. So I moved on to the next stage, which is to try to develop this curve and adjust this curve to have a very straight linear section here in the middle. So never ever have I gotten this to show up on my scope after hours of trying to make it happen. Following the instructions verbatim in the receiver manual, no. I get all kinds of weird stuff, but nothing that looks like this. Nothing that you could really rely on or adjust against. Consequently, the radio's performance kept going down, not up. I came in here last night in the evening, basically hell-bent on getting this radio to work. Turned it on, it wouldn't receive anything. So I decided, well, maybe what's happened, there's four, let's put it this way, there's four transformers in series in here. Two of them in the middle are the IF transformers, which I've tuned to give this response curve. So I've left those two alone. But I've continued fooling around with this one, and this one. This one is in the tuner, and as a 2-core transformer, transmits the 10.7 IF signal to the IF. And this one receives the IF signal and plays a trick with it to convert it into amplitude modulation, if I understand it right. So these guys are just doing that wave shape in the middle, and that's set. So I just concentrated on these. Each one has 2 slugs, so that's 4 slugs. How tough can it be? How tough? How tough can it be? Well, pretty tough. I kept adjusting it, looking at my scope, doing all that stuff. Finally I decided, well, maybe what's happened is I've got the 4 slugs now kind of aligned, but all together aligned in the wrong place. Maybe there's another sweet spot down here somewhere, and if I get them all down here, everything would become normal. I'd see the S-curve, thumbs up. So I began to range the slugs further and further. Drive them down to their limit, drive them up to their limit, set them back in the middle, going all over the place. When I was done with that, this receiver did not sound like an FM radio at all. As you tuned it, it chirped, whined, squealed, hummed, everything you could think of coming out of it. Sometimes the squeal's very sharp, very loud. I thought I'd ruined this guy. I've got him so far off track, he's never coming back. I can't get the S-curve to get it back. I got nothing. Until I decided to do what I've done so many times with FM radios and just wing it by ear. So here's how I managed to get it to sound like this again. I didn't quite start winging it by ear at the start. I took the image that was on my scope. I'm sorry I didn't make any video of this. The image was a couple of circles overlapping. It had nothing to do with an S-curve or anything, just a couple of circles, fuzzy circles kind of overlapping a little bit. And I decided what we're really trying to do here is create a balance in the signal. You're trying to create a balance in this. So maybe I could see the balance no matter what kind of image is on my screen. So I took those 2 circles and I started adjusting, and I just tried to clean up the 2 circles. They're more like this, come like this. At one point, with a little bit of a different setup, I had one circle. How can I show this? Let me use something round here quickly. Anything round. Okay, here's something round. This a bit. I have a circle on my scope. It's not like that. It's twisted like this. And so, okay, S-curve, twisted circle, what the heck. So there's a couple different lines in here, a little bit of fuzz. I just kept fooling around and trying to make this side, trying to make it look like a perfect circle turned on its side like this. And I had quite a bit of success. Periodically I would stop, put the antenna back on the radio, tune the radio, this is the antenna here, see if I could pick up any stations. Finally, I picked up a little bit of a voice. I stopped using the scope, started using just my ears, continued tuning the 4 slugs, a little bit, and eventually I got this. So, and what I'm admitting to here is I had to abandon the proper technical approach and use I would call it a skilled or experienced winging approach. And I got there. Oh boy, and I decided to stop at that point. There's a little more that I did. I set up my signal generator here to send a stereo signal over here. When I crank up the 19 kilohertz pilot strong enough, the stereo light will come on. So I turned the level down till the stereo light was weak, and then I continued more tuning to try to make the stereo light a little bit brighter. My thinking there is all I'm doing is just letting more signal through the radio by getting it tuned a little bit better, so the 19 kilohertz pilot can be picked up a little stronger. I managed to get the light just a wee bit brighter. It was pretty close to ideal alignment. I'm not sure. Couldn't get the light to come on with any FM station at all. So I have a radio here that sounds pretty good in mono, will not flip into stereo unless I hit it with a strong signal from a signal generator. And that's where I am today. So that's where I'm going to pick up from. Now, the last thing I want to do is discombobulate this thing again. So I went to bed late last night. I was happy, but really worn out to get to this point. So this has been one of the most difficult journeys I've taken. got all balled up in other equipment. Hey, for a while I was using this. For a very, very short while. I was using that guy too. Throwing the kitchen sink at it. Eventually I brought in this guy. You may have seen the video I posted just about this one. Even this became a little bit tricky to just introduce into the shop and that. So where am I now? I can't use this generator anymore. There's a problem with this meter, and I'm afraid I'm going to damage the meter if I use that signal generator. So he's out of the picture for the moment. I really don't see the need to get back into this one. I'll leave that guy aside. I think all the work can be done at 100 megahertz, and that's the output of this signal generator, which I better turn on because it takes quite a while to stabilize, about 20 minutes to stabilize. I put this guy in. I think he's going to prove useful. Of course, with this kind of modern device, you can specify frequency, voltage, all this kind of stuff. I did do a voltage check with this, where I tried to read the voltage on my scope, and I got conflicting amounts. And I set this to 2 volts, fully expecting this to be right on 2 volts, but my scope suggested not 2 volts. My meter here too, I tried to read the voltage, but I think I was using a square wave at the time, so you can't really rely on this unless this is calibrated for a sine wave. We could check that again if we care to. Bottom line is, I had forgotten. Thank you. A bird flew in and said, "Hey, you've got this test terminal here on your scope with a fixed voltage on it. It's 300 millivolts here. Why don't you just check this on your scope?" Turns out my scope's not accurate. It's reading, it should be reading 300 millivolts here. It reads 250 millivolts. I don't usually use the scope for precision voltage measurements anyway. I rely on meters for that. But just all part of the jumble up in here. Yeah, wow. So I gotta let that guy warm up for 20 minutes. I'm gonna go drink some coffee, think about how to keep myself out of the jackpot. How am I gonna get through this? The last stages of the alignment amount to this. Amount to these steps. I did go through this once already, much earlier on. I think it went out on video. Had little success with it, probably because the bandwidth up here was very tight at the time. Bandwidth is not tight anymore, I think. I've also checked this wave shape using this guy. That's a sweep generator too. When the wave shape is viewed with that guy, it looks a little bit different than when I did it with the Heath kit. It shouldn't look any different. It's the same coils and transformers. What's going on? The signal level, as I discovered, coming out of here is just below the maximum you can put into this receiver antenna and not overdrive it. And the reason I know that is because it's turned to the minimum, and if I turn it up just slightly, this wave shape, which looks, or response curve, which looks like this, starts to change shape quite dramatically. And a little more output, and you can tell, it's like this on my scope, you can tell this is reaching a limit. The rest of the curve keeps coming up, but the top doesn't move anymore. So using that signal generator puts a signal right at the edge of what this thing can tolerate coming in. If you do these alignments, and maybe this is part of my problem here, with too much signal, then you're going to be in trouble. That's about the best I can say. That's why it's, in my mind, if you can get on an antenna and tune in a real station and get somewhere, you might be better off. Because there's no real chance of a regular antenna type station signal overdriving the FM radio. Oh boy. Yeah, so I'm gonna let that guy warm up, let myself cool down, drink some coffee in there in the middle, come back in. I'm gonna finish this guy off. Yeah. Okay, let's get a start here. So using this signal generator producing a 100 megahertz signal swept at 60 hertz back and forth. The scope, you can see there's something causing a sweep. It's the 60 cycle sweep coming from this device. It's not coming out of the scope itself. It's set to XY here. I've expanded this out so it fills the screen, and I have the sweep width set up in the area where the manual says it should be set. The 19 kilohertz pilot is switched off, and that's all you really need to know about that guy, I think. The receiver is tuned to the station we were listening to. It needs to be retuned to the 100 megahertz output of this guy to start with. So let's just do that. Kind of flip it on. Maybe that radio station will still be heard. Maybe not. The antenna connection is going straight to this signal generator now. Okay, volume up a little bit. Well, you can. I've turned it up full. You can hear that station. And of course, having the signal generator connected has nulled it out. Now tuned to where I think the generator should be, right around here. Yep, there it is. See something go by. Okay, we don't need to listen to that. That's just the 60 cycle buzz. We need to hear a little bit of it. Let's see if I can get this light out of there. Nope. It's my overhead light. Okay. And now, because of my cameras, the autofocus on them has just gotten worse and worse. And I'm sorry I even started without getting the focus right. Let me just correct it here. Just take a second. Okay, let me turn the volume down even more here. So you're seeing two humps there. It's really the same hump shown twice because there's no blanking in the sweep. You know, in a regular scope, in the old style TV sets too, the electron beam comes across, it's then shut off and quickly shot back here. You don't see it come back. There's no comeback. This is not that way at all. This is 60 cycles. Can you see the line is a little brighter here and a little brighter there? That's because the electron beam is dwelling at the ends, and it's rapid through the middle. We should really have this right in the middle, and the best way to do that, retune my signal generator a little bit. Here we are. So just ignore one of them. We'll just look at this one. They're both the same thing. We'll just look at this one. So now, see how it's shaped? Let me start by raising the FM input from minimum upwards. So this is the signal reaching the antennas. Now you can see right away there is distortions. As soon as I raise it a little bit, shapes are changing. If I go a little higher, you can see that this whoops, I better point this way. This top part can't go any higher. It's hit some kind of limit, not the limiter. If I had this thing turned up full, that's what I think the response curve would be, and if I have it down like this, that's what I think the response curve would be. And you see it's moving a little bit left and right. My signal generator is not so stable. When I change the output, the frequency shifts a bit. So these are all the things that I've been encountering as I do this work. All these little bugaboos along the way, that when you're trying to do something so precise, can make a big difference. So the first question is that an accurate representation of the response curve, or is that what happens when you drive it too hard? And I tried to answer that question and could not. I'm going to try to weaken the signal. Now I've done this a couple ways. I'll try it again. One is, well, what if I just throw a load across the antenna terminals, like a resistor or something? Just stick a resistor across those terminals and kind of waste away some of the output signal from my signal generator. So what happens if I stick a 100 ohm resistor on there? Look different in shape. Now I happen to be using, shame on me, I'm using a wire wound resistor, so what do you expect? Let me get one now that's not, well, how about a capacitor? There's a capacitor here, its value is I think it's a 0.001. Let's see if I can make contact with this. Just touching it right across the terminals. No, not quite. Try it again. Here we go. Look at the change of the shape. Like now it looks like it's coming in slow here and fairly steep down there. But where's this hump? The side humps are gone. Which is the real one? So that's a capacitor right across the leads. Now there's something I've not tried, and that is to do what they say to do. And I'll tell you why. Let me put the other camera back on. I think I'm going to have to try this. So they offer a little circuit here. You have 150 ohm there, 120 ohm there, 50, basically 56 or 50 ohm across it. This is the coax coming from your signal generator, and of course that's connecting to the antenna terminals. FM antenna term. I think they probably should have written that just right in the middle here. Terminals. I don't think there's an FM ant and a term. I think this is a balanced input. I think. You know what? I don't even know that for sure. I don't even know that for sure. And I got the schematic right here. I mean, it should be. I mean, it really should be. Let's just make sure that that's the case. So here's the FM terminals right here. Internally, these wires run up and they go right into a transformer. That's a transformer. I've never touched that transformer. When I was talking about the 4 slugs I was adjusting, 2 of them are in here, and 2 are in here. And these are the IF cans, in between which I've been leaving alone because I think I've got them tuned right. But no 19 kilohertz pilot light comes on. So it could be I still have it too constrained. 19 kilohertz, maybe outside the range of the... I mean, this has to be really wide, and not just to get 19. It's got to go really way up. It's a big fat composite signal coming into these FM receivers. In a mono receiver, you can just receive the mono part, and they probably do. Just receive the mono part and reject all the rest. But if you're going to go for stereo, you got to eat the whole thing and chew it properly in the radio. I don't think the whole thing is getting through, but I don't know that for sure. So, you know, again, how do you get certainty when you're doing this, especially in a shop of my sort? So one way is to put markers up and to mark these different points on the curve. And you see they've been very nice here and provide that information right here. So you can see if you look at the curve, come down about, what's that, about a quarter of the way. This doesn't look like it, but it might be the 3 dB point down. It might. Yeah, you know, I think you know what I mean. Half power point down here. I don't really know why they picked this spot, but they give you the frequency down here, 10.8, 10.6. So 100 kilohertz across there. And they show another 100 kilohertz down here. So you get 200 kilohertz away from the center, and you should be way down here at the bottom of the curve. This is really, I think, the only way to determine if you've got the curve right, is to put these marks on here and find out. There is another way, but I'm not going to go into it right now. Well, I think I didn't quite finish the discussion about this matching pad. So on the end of the probe from my signal generator is exactly this arrangement here. If you look close down here, you could see a resistor, and there's a couple of resistors inside a plastic tube here. It's exactly the same network sitting there. So this is done. So this is done correctly. Correct termination. Oh my gosh. I just don't know how to proceed past this point. And what is this point? The point is to verify the width of the IF, absolutely. Is there just some other completely different way of doing this? Oh my God. Okay, trying something completely different here. Not sure how it's going to work out. Just wanted to check on the schematic. Where is test point 1? That's the point at which I'm picking off the signal here. See, there's two red clip leads coming here. One is getting a detected output from a small detector circuit that I've soldered in here according to the instructions. And the other clip is actually ahead of the detector diode, so it's this clip lead here is receiving the entire RF output of the IF. And I'm looking at where is test point 1. So here we have this, the second transformers in the IF. First, second, the output is fed into this transistor, and then test point 1 is on the collector, I believe that is, of that transistor up here, test point 1. I've connected my SDR to test point 1 to see what is coming out of the IF. I'm going to show you the result here. Not too sure what to say about it. First thing, just take a look at what's happened on the scope. The signal has been depleted greatly by, of course, hooking up my SDR. My SDR is what, a couple hundred ohms input, something like that. High risk doing this, but nothing got damaged. But I really was gambling when I hooked this up. So let's have a look at what Mr. SDR says about all this. Here he is. Now I've in the past I've tolerated this jumping up and down, but I figured out how to get rid of it. And it's not by any kind of level control. It's by turning off the decay of the image. So I'm going to turn it off so it won't decay anymore. And what it's doing now is the highest readings are being saved on the screen, so to speak. So we'll just give it a minute or two, and that shape has developed. So the ideal shape here would be 10.7 in the middle. 10.7 is where this red line is. You can see this gigantic peak shooting up. And then you would want the shoulders of the response curve. We don't want this peak here, by the way. This should just be coming across nice and flat. And it should start turning down around, let's say at the low side, 10.6. 10.6 is right here. Well, it's not turning down at all. You go to 10.5. 10.5 should be way low on the curve. The curve should be coming up like this. Is this in any way modeling what is going on in this receiver? Or am I fooling myself here? If we go up the other way, we have at 10.7 roughly in the middle, and then 10.8 should be just going down the curve. Should just start going down the curve. 10.8 is actually here. And then 10.9 should be bottoming out. The curve should be done pretty well. So it should be way down here. It should look like this. And like that. That's not what I got here. Wow. Is this something I can utilize with this huge jump here? Is this real? Is this what's causing all the nonsense? This incredibly sharp response right at 10.7. Good questions, Jim. I don't know the answers to it. Now, if I just turn up the decay here, the S decay, briefly, it sort of erases it, and we can let it go again. You see, it'll build up to pretty much the same shape. I've now put the third watch on, and I'm even less sure of what time it is. Wow. Would I dare to try to align the radio using this image? Of course, it can't be stable like that. It would have to have some decay in it. So we'll just pull this back a little bit. Oh my gosh. The problem here is if I realign the IF, which I think is done correctly now, the moment I start working on it, I won't know what I got. And the only way to get it back to what it was would be to drag down the Heath kit, sweeper set that thing up. My options are so limited here. Radio sounds fairly good. Could it sound good with, if this were true, let me stop the bopping again. Okay, so if this was true, if this was actually the response, these funny peaks way out here, it's very symmetrical, really, isn't it? There's 2 peaks here, there's 2 peaks over here. It's really quite symmetrical. Going all the way out to 10.5 and letting all that in, I don't know, off the top of my head, I cannot tell you where the next channel starts. Somewhere over here, the next channel starts. What frequency would that be at? Oh my gosh, what's the channel separation on FM radio? I got no idea. Let's see, we got 10.57. I don't think it's very much. Couple hundred? I'd have to look that up. If it would have to be more than a couple hundred. Let's say if it's a couple hundred, so you'd go 400 away to find the peak at the next station. So you go 400, you'd be 10.1 somewhere in here. There'd be a station. Yeah, you really want the response curve way down like this. Let me turn the radio. I'm gonna turn this up. I'm gonna switch off the radio here. Okay, well that's what exists without the radio running. Nothing. I'll turn it back on. Is hooking up my SDR this way throwing the radio out of whack? I'm on the other side of a transistor, isolated away from, more or less isolated away from the IF transformers. Why would I think this is incorrect or untrue? Why would I think that? Because I've become so gun shy I don't believe anything anymore. Except my ears. That's the only thing I seem to be able to believe. And what if I just said the heck with all this stuff and just tune that baby by ear? Got me to a good spot as it is. Without touching the IF. I did not touch the IF. The issue here is the IF correct? Is there another way of doing this? Is there another way of doing this? Oh my gosh, what if I feed a signal in to the IF at 10.7, just a single frequency, no sweep, measure the output somehow, move the frequency to 10.6, measure it, 10.7, measure. And when I'm all done, would I look at it and go, yeah, that's right? No, you know what? I just have another watch on my wrist again. Where in the world is certainty? Oh my gosh, I gotta stop and think about this a little bit before I do what I did last night, which is start twiddling things so far out of whack, I have to take a superhuman effort to get it back. I can do a little bit of twiddling, have a flag on my tool now so I know how much I've turned it. Well, one way to find out if this display is really the IF response is to twiddle the IF a little bit and see what happens. I got sweat on my hands. Where is my tool? Yes, I can't find it. Oh my gosh, where'd it go? There it is. Okay, so what I'm going to do is I'm going to be putting an alignment tool into one of the two IF cans and one of the slugs. I'm going to move it. I'm going to watch this display and see what happens. This is I'm going to sink the ship here. Spent a long time getting this IF to be what it is. Okay, looking at the flag. Okay, one big rotation. Wow. Let me go back a bit. That's pretty interesting. I mean, I was able to set that peak at 10.7. I don't like the peak though. Hey, let's go down. We'll do the lower slug in the same transformer here. Look at that. putting it back. Go the other way a little further. I feel like I have tremendous control, is what this is, compared to everything else I've been doing. Okay, let's go to the other transformer. And I've discovered a much better way of doing these things. Here we go, other transformer, top slug. Okay, back. That was like a quarter turn, not even a quarter turn. Okay, going down to the lower slug. Get in there. So in each case it seems to move the peak around, but it doesn't seem to change the shape of things very much. Except that first one, it eliminated this. I had it tuned way off though. I mean, if this is a real response curve, that's a big problem, isn't it? That 10.7 super peak there? Is that because, it's not because of the radio tuning, the SDR, because if I just tune it here, tune it there, it doesn't do anything to this shape. It's not a response of the SDR. I think I can shape these now. There's one more. There's the transformer in the tuner. I'm committing suicide here by doing this. But again, I have a flag on my tool, so I can return it to where it was. Okay, so I'm going to turn the upper slug in the transformer in the tuner. Go a little further. Bring it back. Certainly, this gives me the feeling of tremendous control over what I'm doing. This is the other slug in the tuner. Oh, look at that. It doesn't seem to change the that peak. It's moving the hump around. I mean, oop, so much for that. What I bumped the upper slug. Put it back. Get down the lower slug. Oh, look at that. Oh my gosh. Based on what I did last night with my ear, this thing is way out of tune now. Let's bring it back. Starting to get the flat top. Of course, I didn't count the number of rotations on the flag, so I don't know where I am. Let's just go right on past. Okay, I've hit the limit of the slug. I can't move it any further. I actually got stuck there for a minute. Get my tool in there again. Well, that's pretty interesting. So looking at that now, I can see at, you know, if I change the scale here, I might be able to get better numbers to come up. Let me just expand this one step. So there's 7, 6, 5. Good. Okay, this is a little bit of a better arrangement, because what's supposed to happen is it should be level out to 6 more or less, and then way off to 5. It should look like this. How much of this is from the SDR itself? Can I knock these down? I don't know how I can do that. How can I do that? Let's twiddle a bit. Okay, so I'm going to go back to the IF transformers, starting again with the first upper slug. So this shifts the frequency around. Doesn't seem to change the shape. Let's pick it back. Okay, the upper slug on the other can, assuming these are, you know, kind of done the same way, it moves the frequency around. Moves that peak around, but it doesn't change the shape. Okay, 2 lower slugs. Back to the first can. Lower slug. Tell you what, we can do this with a radio station playing. Now, this is a bit of a hopper here. It wants to hop around. There we go. And the lower slug on the other transformer. Whoop, whoop. Did I not get the lower? No, I don't think I did. I think that was the upper one. It can be tricky to get through. The slugs are close together. They have to the hexagonal openings have to align. I'm in the lower slug now. What's going on with this one? That's totally interesting. The whole peak disappeared. Come back. Okay, I'm going to tune in a station. We're going to listen to this. Now, I think there's a good chance it may not receive it all the way I have it hooked up. But let's give that a try. So what I want to do, I want to take off the sweep. You know what I didn't do? I did not try adjusting the sweep. Let's go back to that for a sec. So sweep width here. I have the advantage of seeing what's going on the scope too. So this is reducing the sweep width. It's now minimum. Well, it's a nice balanced display. Okay, increasing sweep width. I couldn't tell you why it looks the way it looks. Well, that's interesting. One side got there first. Well, that's odd, isn't it? You know, it could be. What's going on here? How come it's like that? Have I not got this tuned in properly? So that's minimum sweep width, tuning the output of the signal generator. Yikes. Now that's interesting. I've tuned totally away. Hey, we might have found something. I think what we're looking at now is just the noise signal in the IF. We can listen to this, for crying out loud, right here. That's mighty loud. Okay, enough of that. Now the shape is, ignoring this gigantic jumping peak here, 10.6. It's, you know, if this were rated like this, it would be just about right. 10.8. Using the noise. Why not use the noise? Let me turn the speaker up on the radio. What do we hear? You hear that? Noise. If I tune the radio, at this point, I hear a little bit of a radio station in there. So I don't have an antenna connected. Oh, maybe that's a cat meowing at me outside, I hear. Okay, I'm going to tune the radio again. Yeah, that's a cat outside my door, if you heard that. If I want to pick anything up, it has no antenna. And this is the signal generator to some degree. Oh, cat, please. Making yourself known, are you? Peanut? What's up? What's up, buddy? Want to go again? Okay, hang on. I have to go and satisfy my poor kitty here. Okay, I'm just going to leave all this as is. Hang on there, cat. Okay, so what you're listening to is the hiss of the receiver with no antenna at all connected to it. Nothing. No sweeper, no nothing. I'm just going to turn the speaker down a little bit so you don't listen to it. And that's the stabilized display here. If I just take the decay off, that's what it looks like. Now that looks like, you know, your basic IF response curve, very, very tight. That's what it looks like. Extremely tight. Yeah. Is, again, you know, is this really representative of what the radio is doing? Now I can move the SDR tuner way off, so it doesn't do anything. It just, wow, it just doesn't look like this. You know, it should come up and be kind of flat and go down. Not quite be like this. Let me put the decay off again so we get a stable picture. It's nice and smooth. Hey, let me tune in a station. Let me tune in a station here. So I'll put the little decay back in. No antenna. So can we pick up a station? I don't know about that. Tuning around. There's a 1 second, almost a 1 second delay on the SDR. So you're going to hear something in the speaker. You won't see it for a second. Some kind of a tone or signal here, and there's terrible backlash in the tune. Not backlash, but the play in the tuning of this radio. So that's very curious. I'm barely turning the tuner, and it's jumping into this kind of stuff. You know what? For crying out loud, I got the AFC on. Let's turn the AFC off. Doggone it. I should not have been on all this time. Okay, what's all that? Well, I got stuff hooked up to the back of the radio. That's probably what that is. Okay, let's get a station. I'm going to hook up the antenna here. What we get. I'm sure you understand this is all experimental what's going on here. That's my screwdriver going into the antenna screws. There's the antenna. I really think noise should work well at defining the oh my gosh, what have I got there now? Where did those hums come from? Oh, what was that? Is that me? I'm not doing anything here. I'm waving my arms around. Okay, let's see if we can find a station. I'm going to disconnect the SDR here. Ah, you know what? I've got this yeah, what comes out of the speaker is probably disturbed by the detector circuit I have in here right now. Let's see. The tune. Okay, so what I'm going to do is I'm going to remove that little circuit so we can hear the radio more clearly. Oh, getting worn out here. Power off. So that's a good station to listen to. That's the CBC. It's a mono transmission. Yeah, for some reason our CBC is all mono. It's a mono transmission and almost always talk. Although I think they were just getting ready to introduce a song there, weren't they? Okay, so I'm going to desolder once again this little test circuit here. It's disconnected, and now I want the SDR to be connected to the test point in there, same place it was just connected. Get this out of the way more. Right there. Well, let's not have it on there right to start, because again, this is the SDR is a load. Can isolate it a bit. Probably get away with isolating it a bit. Let's see what this radio sounds like now. Okay, tuning.
In our culture, our many cultures, like insecurities and depression, or not being like the true man of the house all the time, it's looked upon as weakness. I use that.
It brings to mind what we were talking about just maybe 5-10 minutes ago, when we were talking about that.
Strong, but there's a bit of distortion in it.
More about your own black identity.
Take this out.
Music and through other people's music. My question is,
I shouldn't do anything.
How has that discovery about the
Now,
black part
what
of yourself
happens if
gone
we
through
stick
your
the
own
SDR
discovery?
on? Yeah, risking my SDR
I
here.
feel like it's still yet to reach its like heights. I feel like I still need to learn more and still need and possibly
Pretty much
learn
kills
where
it,
I can
eh?
take it. And I think that curiosity
Okay,
by
let's
itself
isolate a little
pushed
bit.
me to make better music.
Small
Because I feel like I'm
capacitor.
going into a chapter right now where I do need to recreate or come at music in a different angle. So I think right then and there, that's a perfect way to start.
It's a really powerful record, and I appreciate the telling me a little bit about your story today. And thanks for talking.
That's not much.
Thank you so much for taking the time.
We're going to have to
Honestly,
see
I
what's
really
coming on the
appreciate it.
SDR now. Playing music. Stupid of me. I meant to turn the volume down and I retuned the radio. So while they're playing music, I can't do this on camera. So I'm going to stop the camera. Yeah, I'm just going to work away here with this music, see if I can get things set up for when they're talking again. Well, this can't be the CBC. They don't have advertising on CBC, so I got a commercial station here. So you can't see what I'm doing. I've got a 100K resistor on the end of my antenna lead to the SDR. I'm going to touch it to that IF output spot. Look at that, and no disturbance in the radio. So here's what I'm going to do. I'm going to solder that resistor into the test point so it's sticking out. I'm going to clip on, see what happens. Whoop, 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 hey, I'm going to get a copyright hit. Careful, man. Okay. Okay, let's turn it back on. Where'd you go? Turn down. Still playing music there, so. Let's take a look at the SDR, even though I have the sound down. I will tune around to try it. Oh. Yeah, we don't need to listen to it to see this. Now, what does this mean? Ooh, that was interesting. What is going on? Let's see. Okay, that's what's going on there. I guess you can see the beat of the music in there. So, this is quite interesting to me. First of all, it says we're not on 10.7. Now, I did fiddle around with the IF like a knucklehead, and where's the big peak? Where's that crazy 10.7 peak that was sticking out the last time? That's gone. Okay. What now? If I twiddle some of the slugs in the IF, I'm gonna start with the one I always start with. It's top slug of what I call number one. What happens here? Now that's music. That's not me. Here we go. Went down, up, up, down. Okay, we're not even listening to this. That's it. Okay. Now I'll go to the top slug of the other transformer for some reason other than sensibilities. Go up, take it way up. Interesting. We'll do this. It's at 10.75 though. It's not where it should be. Okay, let's go bottom slug of the first one. And moved it to the left. Okay, still nowhere near 10.7 though. Okay, bottom of the other one. So the way the service manual says to do this is you set the IF to 10.7 and the proper response curve. You then match the output of the tuner to it. I'm not doing that. The tuner transformer could be off too, and maybe that's why I can't push this all the way over to 10.7. There's nothing really there. Okay, I'm going to try that. Mess this whole radio right up again. I'll be in here at midnight tonight listening to it and recorrecting it. Okay, so now I'm in the tuner transformer that feeds the IF signal to the IF. Turn a long way, nothing happens. Oh, don't like it when that happens. And there's a lower slug. Okay. That just seemed to weaken it. Something out to the left there. Oh, let's listen to it now. Are they talking?
So we have for 50 more, 6 minutes. James McBride, Fresh 93.1.
93.1. Okay, so we want to get to 91.5 and go this way. There we are. Ooh, weather report.
High of 26. Tonight partly cloudy, 40% chance of showers, and a low expected of 50.
The following is a new episode of The Debaters. First up,
Oh, great.
a debate on e-bikes and e-scooters.
Listen, feel great.
Then we go to wine country with Erica Sigurdson and Kathleen McGee.
I think we can listen to this without a copyright issue.
British Columbia, from Vancouver, it's the Debater! The Debaters, where comedians fight with facts and funny, and this audience picks the winner. Now here's a radio man with a face for television, Steve Patterson.
Canada, welcome back to the Debaters. It is great to be back here in beautiful British Columbia. This is a province that loves its wine and it loves its marathons. In fact, in the Cowichan Valley, you can even do a wine country run where you race and take in the Okanagan scenery while running from winery to winery. I'm assuming what makes this run distinct is that the roadside sports drinks are handed out by sommeliers. As you run by, they tell you the vintage electrolyte with a distinct bouquet of the color blue. It's a great way to get your artisanal hydration on until you realize you have to spit it all out before you swallow it. Now, ready to meet a pair of debaters who can't keep their excitement bottled up? Yes! These are my people! When this comic swore off deodorant, he absolutely wreaked havoc. It's Peter Brown! Peter Brown, ladies and gentlemen, making his entrance, enjoying the crowd. And this comic once laughed so hard in a butcher shop that his ribs ached. It's Ryan Williams!
Some bad humor here, guys.
All energy all the time, and Ryan is riding into this one. He is riding in on a scooter. He is well protected. He's helmeted up. He's got a vest, and he's parking his vehicle for now. Gentlemen, your topic is electrical scooters and bicycles. Should they be banned? Now, for the rest of our CBC listeners, we're not talking about mobility scooters, all right? We're talking high-speed scooters that blaze past you on sidewalks and park trails. And Vancouver will be seeing more of them as the city has approved a controversial new e-scooter rental program. I haven't ridden an e-scooter myself, but I have a Peloton stationary bike at home, so I think I know what I'm talking about. My Peloton comes with an interactive screen that I can pedal along with, but I have to admit I almost opted for the e-bike version, which is sitting on a chair watching television. Now, for a debate that is actually ready to get moving. So, whereas they are too fast for parks, sidewalks, and bike lanes, and too slow for the road, be it resolved, e-bikes and e-scooters should be banned. Peter, you are arguing for this, please. You have 2 minutes, starting now.
Thank you, ladies and gentlemen. I am here to say enough. Enough of your gliding evil. Enough of your breezy menace. E-scooter riders, let's start with you. I'd like to introduce you to a new concept. Other people. may have heard us. We're the ones who yell, "Hey, watch where you're going!" Or, "Get your head out of your butt!" Or, "Oh no, my flan!" We're the people that you breeze past on the sidewalk. You miss us and our sweet little dog by like an inch. And as you go past, we're always thinking, ooh, that person can afford $6 for a rental. Everyone behold, a $6-dollionaire rides among us. I haven't forgotten you, e-bike riders. I see you cruising along, wind in your hair, shoulders back, chest out, feeling like Peter Fonda, an easy rider. But what you look like is a guy who can't have a motorcycle for mom or police reasons. You may feel like a badass. What you look like is a guy who can't make it up onto the curb because you have noodles for thighs. I have more devastating insults to deliver, but I better get out of the way. I better make a space because there's a scooter coming through. But let me say this. Listen, scooter trash. It's time to walk away and leave scooters behind. I know you can do it. You them in front of my house all the damn time.
Peter Brown, ladies and gentlemen. Peter Brown coming
Scope
out
lead.
swinging against
Oh.
e-scooters and e-bikes.
What a dummy.
Now, here to tell us why we should put the pedal to the metal when it comes to e-bikes and e-scooters, it's our one and only fast-moving Ryan Williams. Did you not see how much fun I had earlier? When was the last time you ever heard an adult say, "Wee!" and it wasn't followed by, "Need to talk about your drinking"? Commuting sucks. Monday morning driving, taking transit to your job, knowing all the times and all the things that you put off Friday afternoon are back, and this time they're urgent. Make commuting fun by biking or scootering to work. You know what's not fun? Showing up drenched in sweat, getting caught using the sink as a second shower. Quit pedaling and pushing like a slob, and start gliding with e-scooters and e-bikes. The E stands for electric, but it feels like E, for everyone watches you with jealousy as you glide by.
I'm just listening to the show now.
Much like me after some COVID weight gain, e-bikes have a thick, heavy lower base. Don't like sitting? E-scooters are for you. Millions have switched to standing desks. Let's switch to a standing ride. E-scooters have a thick base with all-terrain tires. Pebbles, the toes of your enemies, are no match for these technological wonders. Join me, Canada, and leave Peter in the dust. Ryan Williams, ladies and gentlemen, he is worked up about this. It is time for us to speed right into the bare-knuckle round. We're asking if e-bikes and e-scooters should be banned, so give each other the gears and no coasting. If you turn into a motor mouth, you'll get too tired and may not be able to handlebar it. Yes, these puns are bespoke. And hopefully, they ring a bell. No one on an e-bike thinks they're Peter Fonda. We're exercising like Jane Fonda.
What exercise are you possibly getting?
10.7 I'm putting on here.
Oh, good. So you're making it even more dangerous. High five.
Why do you keep calling us guys? What about guys?
Fair enough. Of course, women could ride e-scooters. Theoretically,
Whoops.
you could ride one while sober. It's just that it's never happened. Also, because you make a good point about inclusion, I'll just... Ryan,
No connections.
Is Ryan this is true Australia. Gold
10 volts on that terminal. 8 megahertz affecting it. 8.6. No connections. Wow. Oh, it's dangerous having this in the shop. I'm ruining the show. Lower the voltage. Voltage is 0 on here now. Change the frequency again. 13, 12, 10, 10.7, right there. 0 output, still affecting it. There must be something radiating right out of it. Something like that's going on. Oh my gosh, I can't turn this any lower. This is not the great thing I thought it was going to be. Okay, the idea was 10.7. Loading into the radio, I want to mark 10.7 on the SDR. Let's see what we got there. Maybe we got it sitting there. Yikes. Okay.
Heavier than a bicycle, many riders injure themselves while doing what? Peter Brown.
Lifting it onto the bus, they're that lazy.
I've always wondered that. That's 1 point. Ryan Williams. High fives. Injure themselves while attempting high fives.
Yeah, coming onto each other, it's called a dual high five. It's a very tough maneuver. We've lost a lot of good people that way.
I mean, I'm not going to argue with that. The actual answer is dismounting the e-bike. They tend to flip over. I don't want anyone to get hurt, but I would love to see a couple videos of that. That is the firing line, everybody. Time for our fantastic for us here tonight. But first, here to tell try and e-bikes and e-scooters. From Ryan Williams.
13 fatalities from road traffic collisions were recorded in Canada. Every year since that number has gone down because we banned cars. Kidding! Rules, regulations, restrictions have decreased that number every year. We don't need to say buy e-scooters and e-bikes. We need to say buy laws. Here's some rules I've come up with to make everyone safe. Don't ride drunk. When you're drunk, the E stands for emergency room. Stay off the sidewalk. It's called the sidewalk. And let us in the bike lane. Cyclists, we're not going to steal your weird spandex clothes. Wear a helmet, follow the rules of the road, and let's have some fun. We deserve it after what we've been through, everyone.
Ryan Williams. Well said. Well said, young man. Those were good points in there. Now, here to remind us why he'll never backpedal on the banning of e-bikes and e-scooters, here's Peter Brown.
Thanks, Steve. E-scooters. Everyone says they're convenient. Sure. Why walk 3 blocks when all you have to do is download the app, set up an account, create a password, enter your credit card information, scan the QR code, and the QR code because it's mostly scratched off, manually enter the QR code. By that time, you could walk there and back. Convenient. E-bikes. E-bikes. So you like biking, but not the part where you're doing the biking. You all perfectly still with your arms by your side and call that audience members, be honest with yourself.
That's a 10.7 signal coming from my signal generator, verifying the SDR is accurate.
Some great points on why we should ban e-bikes and e-scooters, and Ryan Williams will with a passionate argument on why we shouldn't. Audience, let's hear from you. Who agreed with Peter when he put his foot down about e-bikes and e-scooters and proclaimed, "I'm with the band"? Peter Brown. Yeah. A lot of love for Peter. And who got a real charge out of Ryan's electric lecture on why we should keep on Ryan Williams? Pretty close. It is pretty close. It was well done on both sides, but I've got to give this one to Peter Brown. We got to ban the e-bikes and e-scooters. And before the ban sets in, Ryan is taking his scooter and getting out of here. Big hand for Ryan and Peter.
Okay, so if you don't quite follow what's going on there, this is a well-known Canadian radio show in which they have two Canadian comedians come out and debate a stupid topic. And it's just meant to be funny all the way through. And you might be discovering now that Canadians like pretty simple humor. So, okay, what I'm trying to do while we're listening to that is move that peak to 10.7. I verified that 10.7 is where the red line is. The SDR is accurate. So that's what I'm doing while we're listening. So we're going to bring out two new comedians and do another comedian off here.
Confident and ready. And this comic once believed when the knitting gets tough, the tough gets sewing. It's Kathleen McGee. Kathleen McGee, look at her. She is ready. She's waving to the adoring crowd. This is a great topic, and I think we've got the right people for the job. Your topic is wine. Should you know how to fully taste and appreciate it? All right? Let's figure this out once and for all. Now, I didn't learn much about wine growing up. My dad did make his own wine in a spare bedroom in our house. And let me tell you, he didn't learn much about wine growing up either. Anytime I complained about the bottles having their own room while I had to share one with my brother, he said, that's because there's a chance that the wine will be worth something in the future. Now for an debate with a rosé feature. So, whereas a good bottle is said to be like poetry for the senses, be it resolved, every wine drinker should know how to taste and appreciate fine wine. Erica, you are arguing for this, please. You have 2 minutes.
A no caller.
Thank you. Firstly, I'm very excited to find out that I'm not drinking too much wine. My senses are just super into poetry. When I first dipped my toe into the world of wine drinking, the wine came in a 4-liter jug with a little finger loop and did taste like numerous people had in fact dipped their toes into it. But a few years later and many wine tastings later, I have learned it sounds so much more refined to say something tastes earthy rather than yuck, this tastes like bloody feet. When I finished a few everyday beverages where you can get drunk and still be an elitist, right? Talking about the color and how it dances on your nose, you cannot do that with a White Claw. Opening a fine bottle of wine
It
is
may
an
be
emotional
an issue of how the radio's tuned.
I've heard people say
Let me
that
try
the sound of
tuning it.
laughing is the best
So
sound on
difficult.
earth. Have you heard the sound of
Yeah,
cork
that's all it
when
was.
it pops out of a bottle of wine? Yeah. I'm sorry to say this, people, but if you're walking out of a wine store with a box of wine, people are snickering. Oh, sorry, that's a fancy word for laughing. My point being, if you're going to be a wine drinker, you should strive to refine your palate so your friends and family consider your wine drinking an educational pursuit and not a problem. Thank you.
Erica Sigurdsson. Yeah. Erica Sigurdsson trying to convince us that we should all know how to taste and appreciate fine wine. I've known Erica for a while, and she has done the research, everyone. Now, to tell us why her disdain for wine appreciation is anything but sour grapes, it's Kathleen McGee.
Thank you. I know nothing about wine. I don't even know how to uncork a bottle. Do I drink most of my wine out of a coffee mug? Yes. Do I prefer box to bottle because it's more fun to pretend that you're milking a wine cow? Of course. Do I know how to blow blow up the empty bag from the box so I have a handy and comfortable pillow? Absolute. All of this doesn't make me a better person. It just makes me less pretentious and more fun to be around. I went on a wine tour, and there was a group of wine experts mixed with my group of box wine connoisseurs. My friends and I were horrified to see that these people were spitting their wine out. How do you get a buzz by spitting the wine out? I was always told the lady never spits, so I guess we all know who the ladies in the crowd were at that time. Thank you. I mean, a few of us did pee in the vineyard about the match. Alcohol isn't here for taste. It's there to help us loosen up, be more fun. Anyone that says they drink wine for the taste also reads Playboy for the articles. Thank you.
Kathleen McGee. A nice, common sense argument on why we don't all have to appreciate wine the same. She is a box wine connoisseur. Let's get ready for some vintage puns in the bare knuckle round. We are debating the importance of appreciating wine, so don't keep your jokes bottled up. You want a nice finish. So get your opponent over a barrel to give their hide a good tannin. If you are a successful champagne in the butt, you'll hit all the right notes and make the crowd go, book, yay!
I will never understand why anybody spends $300 on a bottle of wine. You don't need to spend $300 on a bottle of wine. You have to spend like $20 to $30 on a fancy glass. Every wine is good if it's in a fancy glass. Oh, Kathleen. Can I show you my example of a fancy glass? Yes, please do.
Okay, Kathleen is she's walking off stage here. She's coming back with...
Right here.
Oh, that's, Kathleen, I'm not sure that's the name of a wine.
It's a vase.
It's a vase. For flowers. You drink wine?
Is it fill it to the top? Not like those idiots at the restaurants, they only give you this much. Ridiculous. I mean, I did once go to dinner with Kathleen, and when they decanted the bottle of wine into the very fancy decanter, she did drink right out of it. Here's the thing, so you don't even have to spend $300, but let's aim for at least 12, shall we? That was long-winded and bold, just like wine. Also, can I ask you not to pee in an orchard? Like, that is exactly why I have so much trouble figuring out the acidity of the soil.
That's a good place to stop the bare knuckle round, everybody. We're debating whether
There it
everybody
is.
know how to appreciate wine on the Debaters on CBC Radio 1, or maybe you're listening to us on the app, or maybe you're here. It is time now for the firing line. In my hand, I have a list of questions on wine appreciation.
No, it
Brought to
isn't.
you by Fizzy Wine Coolers.
More to do.
Fizzy Wine Coolers, we're taking over the Carba Nation. In WineMag.com's list of 10 wine tips for beginners, what is the very first thing an aspiring wine appreciator should do? Kathleen McGee.
Embrace their depression.
Enjoys that one. 1.5 points. Erica Sickerton.
Find a shirt with sleeves.
Is that no? Long sleeve?
Yes.
All right. The actual answer is buy stemware. Kathleen, stemware.
There's a stem. It's just all stem.
That's better.
In the wine tasting film Sideways, what does Paul Giamatti's character absolutely refuse to do?
Oh, ditch his loser friend.
I mean, that is sort of the plot of the movie. We were looking for something wine-related. Kathleen.
Drink wine with a straw. What? It gets you drunker faster. It's science.
Didn't realize you had your master's from U of A.
I do. That's U of AA.
Whoa! Bonus point for Sickerton. He refuses to drink Merlot.
What's Merlot?
There it is. That's the firing line, everybody. it's almost time for the audience to vote here at Vancouver's York Theatre. But first, here to tell us why talking about appreciating wine makes her head spin and causes her to see red, it's Kathleen McGee.
Being blissfully unaware is a great way to go through life. No one is going to be impressed that you can tell that a certain wine was aged in an oak barrel or a concrete container. I actually had to Google that because I thought all wine was made in bathtubs. Or Steve's dad's bed.
It was the bedroom, it wasn't the actual bed, but yes.
Okay. So remember, you can understand how wine is made and how to taste and appreciate it, or you can be a good time and then just enjoy it for what it is. A fun way to get purple teeth, stain your favorite dress, and get in a fight with someone you love.
Kathleen McGee. The honesty of Kathleen McGee shining through, winning them over here in Vancouver. Let's see, though, now to tell us why her views on wine appreciation have aged so well they're vintage, it's Erica Sigurdsson.
Thank you. In the competitive world of being a grown-up, knowing a thing or two about wine can be just the emotional boost you need to get through yet another dinner party with people you barely like. Swirling a glass of Tempranillo while talking about Bordeaux gives me just the edge I need to get people to walk away from me. If you're not going to learn about wine and try to drink better wine, what is the point of drinking it? That's why they don't sell gift bags for boxes of wine at the liquor store. Kathleen, your taste in wine should improve with age, just like your taste in men. Because in both cases, it's all about the length and the finish. Thank you.
Erica Sigurdsson gets saucy at the end there. All right, it is up to the audience to decide by applause who thinks Erica's wine appreciation oration Bordeaux'd on genius. Erica Sigurdsson. Okay. Some nice appreciation for Erica. And who appreciated Kathleen's wine depreciation dialogue? Kathleen McGee. Well, the audience has spoken. You don't have to appreciate wine to drink it. The winner's Kathleen McGee. Big hand for Kathleen McGee and Erica Sigurdsson, everybody. Well, that's all for this week. I'm Steve Patterson saying, remember that fine wine gets better over time, but unfine wine gets even unfiner. Take that, Dad. I'll argue with you again soon, Canada. Good night.
Okay, let's see some other stations here. Very good. Very good. Okay. Oh, that's a very different method I was using there. I'm sorry I wasn't speaking because I was listening to the show while I was listening very carefully to the show while I was doing that. And it may not have been apparent to you, but I was doing a lot of twiddling. And what I could see on the screen is, you have the main hump there that you're trying to work on. And as I move the slugs around, I could see this hump very good. Now, because I'm doing it, I know what to look for. I could see the hump move over here, the hump for that particular slug, and then I could kind of put it back to where the peak is supposed to be. And I did them over and over and over and over while we were listening to that, and verified that 10.7 was where it shows on the SDR, and realized eventually the reason I couldn't move it was because the radio was out of tune. So, the local oscillator and the incoming signal are mixing to not give you 10.7, but to give you 10.6 or something like that. It doesn't matter how much you tune the IF doing this, if the radio's not tuned exactly right, you're going to be in some trouble there. So we're doing all this without paying too much attention to the pointer, because the pointer has no dial behind it anyway, and I've kind of given up on focusing on making the pointer accurate in favor of making the radio sound better. The last test I'm going to do today is simply see if the stereo light comes on when I tune in stereo FM signals. That's what I want to see. We're going to go over here, take a look, see what happens here. Okay, so the FM stereo light. Ooh, nothing there. I'm standing on the camera wire. The FM stereo light is right under here. So if I hit a stereo station, it should come on. I don't even need to listen to it, but we will. Every station's stereo on here, I'm pretty sure. So let's find one here. Okay, no light. Good question as to what I'm picking up right now. Oh, my soldering iron's on. Let's get that out of here. Soldering iron, a lot of stuff issues interfering signals in here. Don't know what that was. Watch for the light. No, not strong enough signals. Stronger signals are coming.
It's reported just under 800 new cases of COVID since yesterday. A small percentage of those hospitalized and in ICU aren't vaccinated.
No stereo light.
About what's next from the province with a media briefing with Health Minister Christine Elliott in just about 2 hours' time.
Sounds good though. No stereo light. Yeah, it's not going to come on. Those are strong enough stations there. There's another one. Nobody wants to do it. Okay, we're going to force it on with the signal generator if I can. I'm going to loosely couple the signal generator output. I'm just going to hang it near the antenna. Okay, now we have to first find this on the radio. Should be a hummy sound. That's not it, is it? That's it. Why no hummy sound? Ah, it's very odd. I've got it in sweep mode here. And so I'm tuning the signal generator back and forth. Okay, I have no idea why it's not. Should be making a big hum, shouldn't it? All right. Quiet as can be. Wow, did I really succeed in doing something great? Now I'm gonna send over a 19 kilohertz pilot here, along with a 1000 hertz tone. You can hear the 1000 hertz tone coming out of the speakers. Okay, 19 kilohertz. I'm gonna crank it up. The light did not come on. That's not good. A little more signal from the signal generator. Not coming on. Now I just have the signal generator loosely coupled here. Barely coupled, really. Okay, more RF output. More 19 kilohertz. Left and right channels. Stereo light is not coming on. What else can I do here to kind of force the situation? Not much, I don't think. Oh, you know what? I didn't have the deviation turned up. Now, don't know if that affects the 19 kilohertz pilot, but that's why we didn't hear the sweep sound. Okay. Okay, so that is a 75 kilohertz a signal deviating 75 kilohertz, like a standard FM signal. 400 hertz, 5 kilohertz. Okay, come on, light. Okay, so I have the maximum 19 kilohertz coming out of here. I'm going to tune the signal generator slightly, which is like tuning the receiver. And with, oh, the light is on. The light is on. The light is on. Now I'm going to turn down the 19 kilohertz here. Turns off right in there. I'm now going to try to hear the stereo. Okay, so got a good 19 kilohertz signal. I'm sending over a left channel sound. Sure sounds like it's in the middle to me. And I will now send over we'll flip back and forth between right and left. Oh, well that seems to be coming now. Left and right, maybe it's the other way around, right? Just depends how I put my speakers. I hear it out of that speaker, not this one. And it's the other way around now. I hear more out of the right speaker. It's thumbs up. Good. Okay. Well, you know what? That's enough for today because look, it's 12 o'clock. And if you watch this entire video, my hat's off to you. Hats off to you. Let me shut this off here. So, thanks so much for watching. Clearly this is a big struggle. I seem to be getting through it. The SDR is extremely helpful at this point over trying to use the more standard techniques with the scope. What lies ahead now are to tune up the multiplex circuit, which is exactly what doesn't seem to be working quite right. I have a number of steps to take to do that. And S-curve. I didn't see the S-curve. Anybody see an S-curve? Thanks so much for watching, and enjoy your day.